In the unending blackness that separates the stars, there is an ocean. It is an expanse so vast, so silent, so utterly cold, that the entire history of our world is but a fleeting ripple upon its surface. We reside on a sun-drenched island in this cosmic sea, a lonely archipelago of planets, moons, and dust, all held captive by the gravity of a single, ordinary star. For all of human existence, we believed this island was all there was, that the ocean between the points of light was fundamentally empty, an unbridgeable chasm of pure nothingness. We were wrong. The cosmic ocean is not empty. It is filled with currents, unseen rivers of gravity and momentum carrying the lost relics of distant shores. For billions of years, fragments of other solar systems, other islands of creation, have been cast adrift, flung from their homes by the gravitational chaos of their birth. These are messages in a bottle, hurled into the void, carrying with them the chemical secrets of their parent stars, the geological history of worlds we will never see. And now, after an eternity of silence, we are finally beginning to read them. It began with a whisper, a phantom in the dark. In 2017, a strange smear of light was detected, a visitor moving too fast, on a trajectory that was all wrong. It was not bound to our sun. It was just passing through. We named it Oumuamua, the Hawaiian word for scout. It was small, elongated and tumbling end over end, behaving in ways we could not fully explain. Then, just as quickly as it arrived, it was gone, slingshotting back into the interstellar deep, leaving behind a trail of questions. 2 years later, a second traveller appeared. This one, named Borisov, was more familiar. It looked and behaved like a comet from our own system, trailing a magnificent tail of gas and dust as it neared our sun. It was a comforting sight, proof that the chemistry of other star systems might not be so different from our own. It was a piece of flotsam that looked like it could have come from our own shores. But these two encounters were merely the prelude. They were the first faint signs of a profound new reality. They taught us to look for the outsiders, the interlopers, the messengers, and so we watched, with new eyes and upgraded instruments, scanning the heavens not just for threats from within our system, but for clues arriving from without. We were waiting for the third one, the one that might change everything. And on a clear, cold night atop a dormant volcano in Hawaii, history began to stir. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, is not one telescope, but a quartet of them, a sleepless guardian standing watch over the night sky. Their mission is simple and stark, to find celestial objects on a collision course with Earth before they find us. Every 24 hours, these robotic eyes scan the entire visible sky, photographing millions of stars, galaxies, and the empty spaces between. Sophisticated software meticulously compares each new image with the one taken just hours before, searching for anything that has moved. It is the world's most advanced game of spot the difference, played out on a canvas of cosmic proportions. Most of the time, the moving targets are familiar, known asteroids on their predictable orbits, satellites winking in the twilight, the occasional newly discovered comet from the farthest reaches of our own solar system. But on this night, the algorithm flagged something different. It was a pinpoint of light, impossibly faint, moving with an unnerving swiftness against the backdrop of the constellation Pegasus. The initial alert was unremarkable, just another string of numbers and coordinates in a torrent of data pouring into servers around the world. It was designated, provisionally, with the sterile label of its discoverer. But as observatories across the globe awoke and turned their gaze towards this new apparition, a strange story began to unfold. Astronomers plotted the first few points of its trajectory, expecting to see the familiar, gentle curve of an elliptical orbit, the signature of an object forever tethered to our sun. Instead, the line they drew was nearly straight. With each new observation, the path became clearer, the mathematics more certain. This was not a gentle curve. It was a hyperbola, a stark open-ended arc that screamed its origins to the heavens. This traveller was not from here. It had entered our solar system from the interstellar gulf, and it would return to that same gulf once its brief visit was over. The news rippled through the astronomical community, first as hushed emails, then as frantic alerts on observation networks. It was official. We had found the third one. It was given the designation 3I/Atlas, the 3I for third interstellar object. And as the first detailed studies began, it became clear that this visitor was unlike either of its predecessors. It was not the inert, mysterious spindle of Oumuamua, nor was it the conventional, predictable comet that was Borisov. It was something else entirely, something complicated. To truly grasp the significance of 3I/Atlas, we must first journey back to its enigmatic forerunners. Oumuamua remains one of the greatest astronomical puzzles of the 21st century. It was detected only after it had already whipped around the sun and was speeding away from us, giving humanity a fleeting, frustratingly brief glimpse. Its light curve, the way its brightness fluctuated, suggested a bizarre shape, perhaps like a cigar or a flat pancake, 10 times longer than it was wide. No asteroid or comet in our solar system looks anything like it. More perplexing still was its motion. As it receded from the sun, it was accelerating, pushed by some unseen force. With a normal comet, this is easily explained by outgassing, as solar radiation vaporizes ice on its surface, creating jets that act like tiny rocket thrusters. But the world's most powerful telescopes, pointed squarely at Oumuamua, saw no such outgassing, no coma, no tail, just a pristine point of light. This led to a cascade of extraordinary hypotheses. Perhaps it was a new kind of object, a nitrogen iceberg chipped off a Pluto-like planet in another star system, whose outgassing would be invisible to our instruments. Others, more audaciously, suggested it could be an artifact, a piece of alien technology, a solar sail tumbling through our system. We will likely never know. Oumuamua is gone, a cosmic enigma that has already dissolved back into the galactic ocean. Then came 2I/Borisov, discovered by amateur astronomer Gennady Borisov. It was a breath of fresh and somewhat reassuring air. From the moment it was spotted, it looked familiar. It sported a magnificent dusty coma and a long, graceful tail. Spectroscopic analysis showed it was rich in water and other compounds commonly found in comets from our own Oort cloud. Borisov was profound, not for its strangeness, but for its normality. It was the proof of concept, the confirmation that the building blocks of solar systems, the icy leftovers of planetary formation, are common throughout the galaxy. It told us that other stellar islands likely resemble our own. So when 3I/Atlas was discovered, the world of astronomy had two templates, the bizarre and the ordinary, the alien and the familiar. The central question on everyone's mind was, which would this new visitor be? The answer, it turned out, was neither, and both. As 3I/Atlas journeyed deeper into our solar system, its behaviour grew increasingly perplexing. Initially it appeared inert, a dark reddish-hued rock much like Oumuamua. But as it crossed the orbit of Mars, something began to happen. The James Webb Space Telescope, with its unparalleled infrared vision, detected a faint, tenuous cloud of gas forming around the object. A coma. But this was no ordinary cometary atmosphere. Spectroscopy, the science of breaking down light into its chemical fingerprints, delivered the first shockwave. The gas cloud around 3I/Atlas was not dominated by water vapour, as is the case with nearly every comet we have ever studied. Instead, it was a bizarre cocktail of methane, ammonia, and complex hydrocarbons. And within that chemical signature were isotopic ratios that made no sense. Isotopes are different versions of the same element, with more or fewer neutrons in their nucleus. The ratio of these isotopes acts like a planetary DNA test, a unique identifier for the material that formed in a specific part of the solar system. The ratios in 3I/Atlas were unlike anything found in our Sun's family. They pointed to a birthplace in a stellar nursery with a radically different chemical history, perhaps one seeded by the ancient explosion of a rare type of supernova. This was not just a piece of another solar system, it was a piece of a different kind of solar system altogether. Then came the second mystery. The outgassing was not constant. It occurred in sudden, violent bursts, lasting for a few hours before shutting off completely. The object would flare in brightness, then dim back to its quiet state. It was as if there were geysers on its surface, periodically erupting as it slowly tumbled through space, exposing volatile pockets of frozen gas to the strengthening sunlight. This object was a geological artifact of immense complexity, a fossil from a world whose life story was written in a different chemical language. As astronomers pieced together its trajectory, they traced its path backwards, out of our solar system and into the vast emptiness of interstellar space. Using data from the Gaia Space Observatory, which has mapped the positions and movements of over 1 billion stars with breathtaking precision, they were able to rewind its journey through the galaxy. The calculations pointed to a source. Roughly 70,000 years ago, 3I/Atlas had passed perilously close to a binary star system known as Gliese 754, a pair of dim red dwarfs. It's impossible to say for certain if it originated there, but this close pass could have been the final gravitational nudge that sent it on its long looping journey towards our Sun. Here was a tangible piece of another star system, one with a demonstrably different chemistry, and it was headed directly into our backyard. Oumuamua was a missed opportunity. Borisov was a familiar sample. 3I/Atlas was the Rosetta Stone. A chance to study the geology of an alien world up close, but to do that, watching from afar would not be enough. An audacious idea, once the domain of science fiction, began to solidify in the halls of space agencies around the world. We had to go to it. We had to send a probe. The challenge is almost beyond comprehension. Imagine trying to intercept a bullet fired from a rifle, using another bullet that you must fire from miles away. Now imagine both bullets are moving at tens of thousands of miles per hour, and your target is a tiny dark rock, millions of miles distant in the freezing vacuum of space. This is the problem of intercepting an interstellar object. 3I/Atlas was moving at a blistering velocity of over 30 kilometers per second relative to our Sun. No rocket ever built could simply launch from Earth and catch up to it. Any mission would require a flight path of almost unimaginable complexity and precision. A plan began to form, a mission concept given the name Wayfarer. It would be a testament to human ingenuity and desperation. The Wayfarer probe would not launch towards 3I/Atlas. Instead, it would launch in the opposite direction, towards our own Sun. It would perform one of the most daring maneuvers in the history of spaceflight, a powered Oberth maneuver. The probe would dive towards the Sun, firing its engines at perihelion, the point of its closest approach, where its orbital speed would be at its absolute maximum. By firing its engines at this moment of peak velocity, the probe would multiply the effectiveness of its fuel, gaining a colossal boost in speed, far more than the engine could provide on its own. This gravitational slingshot of epic proportions would be just enough to bend its trajectory and send it screaming out of the solar system, on a course to intercept the interstellar visitor. The timeline was brutal. The launch window was a matter of months. Miss it, and 3I/Atlas would be too far away, its speed too great to ever be caught. An unprecedented international collaboration was formed. Engineers at NASA, ESA and other agencies worked around the clock, adapting an existing spacecraft design, stripping it of non-essential weight, and equipping it with a new generation of scientific instruments. A miniaturized mass spectrometer to taste the gases of its coma. A high-resolution imager to map its surface. A ground-penetrating radar to probe its internal structure. This was a one-shot mission. There would be no second chances. The launch from Cape Canaveral was a moment of global tension and hope. The most powerful rocket in the world carried the small, dense Wayfarer probe, a silent ambassador for all humanity, on the first leg of its impossible journey. For months, it fell towards the Sun, a tiny mote of metal against the growing glare. Then came the moment of truth. As it whipped around our star, closer than any probe had ever dared to venture, its heat shields glowing cherry red, its systems screaming under the strain of the heat and radiation, the main engine ignited. For 3 agonizing minutes, it fired, pushing the probe to the very limits of physics, and it worked. Wayfarer emerged from the Sun's glare, not as a captive, but as a creature of the interstellar void, its velocity matching that of the cosmic wanderer it was sent to hunt. The chase would last for years, through the asteroid belt, past the orbit of Jupiter, into the cold, dark realms where the sun is just the brightest star in the sky. 3 I/Atlas, a distant point of light, grew steadily in the probe's telescopic lens. First, a single pixel, then a fuzzy blob, and then, finally, the first detailed images began to stream back to Earth, travelling for hours at the speed of light across billions of kilometres. What they revealed silenced the mission control room. 3. I/Atlas was not a single monolithic object. It was a composite, a bizarre agglomerate of 2 distinct bodies that had somehow fused together in a gentle, ancient collision. One half was dark, cratered, and appeared to be made of carbonaceous rock, similar to some asteroids in our own system. But the other half was completely different. It was brighter, smoother, and crisscrossed with enormous fissures, out of which the intermittent jets of gas were erupting. This brighter lobe was clearly the source of the strange chemistry detected from Earth, a reservoir of exotic ices. It looked like a piece of a planetary core fused to a piece of its crust, a geological chimera. As Wayfarer drew closer, executing its final thruster burns to enter a loose orbit, the sheer strangeness of the landscape became apparent. The surface was not just rock and ice. In places there were metallic crystalline structures glinting in the faint sunlight, formations unlike any known geology. The probe's spectrometers went to work analysing the composition. The results were staggering. The object was rich in heavy elements like gold, platinum and uranium, far beyond the concentrations found anywhere in our solar system. This confirmed the theory that it had formed in a region of space seeded by a kilonova, the cataclysmic merger of 2 neutron stars. We were orbiting the fossilized remnant of a cosmic cataclysm that occurred long before our sun was even born. The probe's radar peered deep beneath the surface, revealing a complex internal structure. The dark, rocky lobe was solid, a dense core of rubble, but the brighter, icy lobe was a labyrinth of caves and voids, carved out by eons of sublimating gas. It was within these hidden chambers that the true treasure was waiting. Wayfarer manoeuvred carefully, flying through one of the plumes of gas as it erupted from a deep fissure. Its mass spectrometer drank in the sample, analysing it molecule by molecule. And it found water. Not just traces, but vast quantities of water ice locked away beneath the surface. And when the isotopic ratio of that water was analysed, a gasp went through the science teams back on Earth. The ratio of deuterium, or heavy water, to normal water was a near-perfect match for the water found in Earth's oceans. This was the smoking gun, the holy grail that scientists had sought for decades. The panspermia hypothesis, the idea that the building blocks of life, like water and organic molecules, could be delivered to planets by comets and asteroids, had always been a compelling theory. But here was the proof that the same kind of life-giving water found on our world exists in other star systems, and that there is a mechanism for transporting it across the vast interstellar distances. 3. I/Atlas was a vessel, a celestial ark. It carried the chemical heritage of a long-dead star system. It told a story of incredible violence, the merger of neutron stars that forged the heavy elements glinting on its surface. It told a story of planetary formation, of a world or a planetesimal that was shattered and torn apart in the gravitational dance of its youth. And it told a story of hope, carrying the very essence of life's potential, water, across the galactic void. It was a messenger that told us that the materials for life are not unique to our island, but a common cargo on the currents of the cosmic ocean. The Wayfarer mission continued for months, mapping every square metre of the alien artifact, analysing every puff of gas from its cryptic vents. It was a triumph of human curiosity, a journey of discovery that redefined our place in the universe. We learned that solar systems are not isolated gardens. They are porous, leaky, constantly exchanging materials with one another over geological timescales. The galaxy is not a collection of discrete points of light. It is a single, interconnected ecosystem. A piece of our solar system is right now likely travelling through another, and we are in part made from the stardust of other suns, delivered to our world by ancient travellers just like 3 I/Atlas. The legacy of this single, wandering object is profound. It has opened up an entirely new field of science, interstellar archaeology. We no longer have to dream of sending probes on million-year journeys to other stars to understand their chemistry and geology. The stars are sending samples to us. With the next generation of telescopes, like the Vera C. Rubin Observatory, we will not find one interstellar object per year but dozens. We will build a library of these visitors, cataloguing their compositions, their origins, their stories. Each one will be a new chapter in the grand narrative of the cosmos, a data point revealing the incredible diversity of worlds forming around other stars. As for 3I/Atlas, its time in our sun's warmth is drawing to a close. Its long, hyperbolic arc is now carrying it away, back towards the darkness. The Wayfarer probe, its mission complete and its fuel nearly spent, will remain in orbit around it, a silent monument to human endeavour. Together, the alien rock and the human artifact will journey on, drifting through the silent ocean for eons to come. Perhaps, 100,000 years from now, they will drift into another solar system, where another fledgling intelligence might look up and see a strange point of light moving against their stars. What story will they tell then? We began by looking at the sky and seeing only emptiness between the stars. We now see an ocean, teeming with the ghosts of distant worlds, with messengers carrying the secrets of creation. We thought we were isolated. We now understand we are part of a galactic conversation that has been happening for billions of years. We just needed to learn how to listen. History awaited us on 3I/Atlas, and it taught us that our own history is inextricably woven into the grand, silent and magnificent tapestry of the stars. The journey is just beginning. The morning of September 1st, 1859 broke over the English countryside with a deceptive stillness. In the quiet town of Redhill, Richard Carrington moved through the cool air of his private observatory, a sanctuary of brass, glass and meticulous record-keeping. He was a man of two worlds, by day, a successful manager of a wealthy family brewery, and by the light of the stars, a premier observer of the heavens. On this particular morning, his focus was not on the distant constellations of the night, but on the singular burning furnace that governed the day. The sun hung in the sky, a massive roiling sphere of hydrogen and helium, yet from the vantage point of Earth, it appeared as a serene golden coin. Carrington adjusted the controls of his heavy telescope, projecting a large 11-inch image of the solar disk onto a screen of frosted glass. This method allowed him to study the star without the risk of permanent blindness, turning the sun's fury into a manageable map of light and shadow. For several days, a cluster of sunspots had been migrating across the solar face, enormous, dark chasms that dwarfed the Earth in scale. They were jagged, complex, and pulsing with an invisible tension that Carrington could sense, even if he could not yet name it. With a sharpened pencil and the steady hand of a cartographer, he began to trace the outlines of these solar blemishes. He noted the deep velvet blackness of the central umbra and the grey, fibrous filaments of the surrounding penumbra. The observatory was silent, save for the rhythmic ticking of a sidereal clock and the scratch of graphite on paper. It was a moment of profound human focus, a tiny consciousness attempting to catalogue the features of a titan. Then, at 18 minutes past 11 in the morning, the sun did something it had never done in the recorded history of the species. From the heart of the largest sunspot cluster, two beads of white light erupted. They were not the dull, glowing orange of the solar surface, but a brilliant, incandescent silver that pierced the projected image with the intensity of 1,000 welding torches. These twin points of light grew in size and brilliance, shimmering with a frantic energy that seemed to defy the slow, majestic rotation of the star. Carrington stared, his breath catching in his throat. He was witnessing a solar flare, the first ever seen by human eyes, though at that moment he possessed no vocabulary for such a phenomenon. The sheer scale of the event was beyond the comprehension of the 19th century mind. Within those two beads of light, the sun had converted magnetic tension into a kinetic scream. It was an explosion of such magnitude that it equaled the energy of 10 billion atomic bombs detonating simultaneously. Yet, because the light travelled across 93 million miles of vacuum, the event was perfectly, hauntingly silent. There was no roar of thunder, no shockwave to rattle the windows of the Red Hill Observatory. There was only the light, cold and terrifyingly beautiful. Carrington, gripped by the realization that he was seeing something singular and perhaps transitory, bolted from his chair. He scrambled down the stairs, his boots thumping against the wood as he searched the house for a witness. He needed a second pair of eyes to confirm that the sun had truly broken its ancient steady rhythm. He found no one. He returned to his telescope barely 60 seconds later, lungs burning and heart racing, only to find that the celestial fire had already begun to diminish. By 23 minutes past 11, the white beads had vanished entirely. The sunspots remained, looking exactly as they had minutes before, but the star was no longer the same. It was no longer a distant, indifferent lamp. It had become an active protagonist in the story of the Earth. Carrington sat back, his sketch unfinished, his mind reeling. He did not know that the flash of light he had just witnessed was merely the opening salvo. While the radiation from the flare had already struck the Earth's upper atmosphere at the speed of light, it was the invisible companion of the flare, a gargantuan cloud of magnetized plasma known as a coronal mass ejection, that posed the true threat. The sun had launched 1 billion tons of its own atmosphere into the void, a wall of superheated gas and magnetic fury aimed directly at the planet. This invisible cannonball was now hurtling through the darkness of space at a velocity of millions of miles per hour. It crossed the orbits of the inner planets with a predatory focus, a wave of cosmic energy that would soon collide with the invisible magnetic shield of the Earth. Carrington, cleaning his lenses and checking his notes, could not have foreseen that his quiet morning in Red Hill was the beginning of a global transformation. He had watched the fuse be lit. He was now waiting for the spark to reach the powder keg of a world that was just beginning to entwine itself in the copper wires of the telegraph. The shot had been fired, and the Earth lay directly in the line of sight. The invisible wall of plasma, a billion-ton wave of charged particles, tore through the void of the inner solar system for 17 hours and 40 minutes. When it finally struck the Earth's magnetic shield, the impact was not a sound but a planetary convulsion. The magnetosphere, that protective cocoon generated by the spinning iron core of our world, buckled under the weight of the solar wind. The magnetic field lines snapped and lashed back, funneling the sun's fury toward the poles, and then, as the pressure intensified, pushing the celestial fire toward the equator. As night fell over the western hemisphere, the atmosphere began to glow with a terrifying, unearthly brilliance. In the Caribbean, on the islands of Cuba and Jamaica, the tropical darkness was not merely broken, it was annihilated. Sailors on the decks of merchant ships looked up to see the sky transformed into a shroud of deep, pulsating crimson. It was as if the heavens had been wounded and were bleeding across the stars. This was the aurora borealis, usually a shy ghost haunting the Arctic Circle, now screaming across the tropics. In Hawaii, the palm trees cast long, sharp shadows on the sand under a sky that shimmered with curtains of emerald and violet, a light so intense that the silver of the moon seemed dull and forgotten by comparison. In the high, rugged peaks of the Rocky Mountains, the effect was even more surreal. A group of gold miners huddled in their timber cabins were jolted awake by a light so piercing they were certain the sun had made a premature and impossible return. They peered out of their windows to see the rugged terrain illuminated with the clarity of high noon. Believing the day had begun, they stoked their fires, cracked eggs into iron skillets, and began to prepare their morning meal. It was only when they consulted their pocket watches and saw the hands pointing to 1 o'clock in the morning that the true, eerie nature of the light dawned upon them. They stood in the freezing mountain air, breakfast forgotten, watching the sky ripple like silk in a phantom wind. While the world stared upward in awe, a more violent drama was unfolding along the copper veins of the 19th century world. The telegraph, the crowning achievement of the Victorian age, was the first victim of this cosmic intrusion. The long stretches of wire suspended across continents acted as giant antennas, capturing the fluctuating magnetic energy and converting it into massive surges of electricity. In telegraph offices from London to New York, the machines began to hiss and spit. Operators were thrown back from their desks as blue sparks leapt from the equipment, the sheer voltage of the sun scorching their hands. In many stations, the chemically treated paper used to record the dots and dashes of Morse code spontaneously ignited, sending plumes of acrid smoke into the air. The most haunting phenomenon, however, occurred when the operators, fearing a total fire, disconnected the heavy lead-acid batteries that powered the lines. To their horror and amazement, the machines did not die. The copper wires remained alive, vibrating with a current that originated not from any man-made source, but from the very air itself. In a famous exchange that would be preserved in the annals of science, two operators, one in Boston and one in Portland, decided to work using only this celestial power. They spoke to one another across the miles, their messages carried by the ghost of the solar storm. For several hours, the sun itself became the battery for the world's communication, a literal manifestation of the star's power flowing through the fingers of men. It was a moment of profound accidental symbiosis, where the most advanced technology of the era was hijacked by a force it was never designed to withstand. This was a world of steam engines, ink-stained ledgers, and horse-drawn carriages. When the telegraph lines failed or caught fire, the impact was localized, a chaotic inconvenience in a society that still moved at the speed of a galloping horse. If a message was lost, it was rewritten. If a wire was burnt, it was spliced back together by men in waistcoats. The 1859 event was a warning shot fired at a civilization that was still largely analog, a world where the most precious records were kept in heavy paper books stored in stone vaults. Yet, as the blood-red auroras faded and the sun returned to its deceptive calm, a fundamental shift had occurred. Humanity had built its first truly global network, and in a single night, the sun had demonstrated exactly how fragile that network was. The event in 1859 was a localized disaster in a world of wood and iron, but it served as a dark mirror reflecting a future yet to come. It was a ghost story for a digital age that had not yet been born, a reminder that the more we weave our lives into the threads of electromagnetism, the more we expose our soft, vulnerable underbelly to the whims of the star that sustains us. The chaos of the telegraph was merely a rehearsal for the total silence that would follow if such a storm were to strike the world of the future, a world where every memory, every scent, and every heartbeat is tethered to the very currents that the sun can turn to fire in an instant. To understand the origin of the fire that struck the 19th century, one must descend far beneath the visible surface of the star, past the blinding light of the photosphere, and into the dark, churning depths of the solar interior. Here, the sun is not a solid object, but a gargantuan sphere of plasma, a fourth state of matter where atoms are ripped apart into a sea of free-roaming electrons and ions. This soup of charged particles is a perfect conductor of electricity, and it is the movement of this fluid that creates the most powerful magnetic engine in the solar system, the solar dynamo. Deep within the convection zone, which extends from the outer layers down nearly 200,000 kilometers, the sun behaves like a pot of boiling water on a cosmic scale. Massive plumes of superheated plasma rise from the interior, cool at the surface, and then sink back down in a relentless cycle of motion. This constant roiling churn is fueled by the unimaginable heat generated in the core, where nuclear fusion crushes hydrogen into helium at temperatures exceeding 15 million degrees. This kinetic energy, the sheer force of trillions of tons of plasma in motion, is the raw material from which the sun's magnetic field is forged. The sun does not rotate as a single rigid body. Because it is fluid, its equator spins significantly faster than its poles. At the solar equator, a full rotation is completed in approximately 25 days, while the regions near the poles may take as long as 35 days to finish a single circuit. This phenomenon, known as differential rotation, is the primary architect of solar violence. As the sun spins, it carries the internal magnetic field lines along with it. Because the centre is moving faster than the top and bottom, the magnetic field lines, which might have begun as simple straight paths running from pole to pole, are dragged forward. They begin to wrap around the sun's interior like thread being wound onto a bobbin. With every rotation, the tension increases. The magnetic field lines are stretched, thinned, and amplified by the shear forces of the plasma. What was once a tidy global field becomes a chaotic web of high-tension cables, buried deep beneath the surface. This is the omega effect, a process of stretching that concentrates magnetic energy to levels that defy human scale. The plasma and the magnetic field are frozen together. The fluid cannot move without dragging the field, and the field cannot change without pushing the fluid. As these magnetic cables are stretched, they also become subject to the turbulent, twisting motions of the convection cells. Like a piece of twine being twisted between two fingers, the magnetic field lines begin to kink and loop. This twisting, driven by the Coriolis force of the sun's rotation, is known as the alpha effect. It transforms the long, horizontal bands of magnetic tension into complex, three-dimensional structures. The magnetic pressure within these tangled ropes becomes so intense that it begins to counteract the weight of the surrounding plasma. The magnetic field lines become buoyant. Like giant, invisible serpents, these loops of concentrated magnetism begin to rise through the convection zone, pushing aside the superheated gas as they ascend toward the surface. When these loops finally break through the photosphere, they create the features Richard Carrington spent his life cataloguing. Where the magnetic field is strongest, it chokes off the upward flow of heat from the interior, creating regions that are thousands of degrees cooler than their surroundings. To the human eye, these appear as dark sunspots, the visible footprints of the invisible monsters lurking beneath. The solar dynamo is a relentless converter of energy. It takes the heat of nuclear fusion and the kinetic energy of rotation and weaves them into a magnetic tapestry of staggering complexity. It is a system in a state of constant, precarious balance. For years at a time, the sun can appear calm, its internal tensions hidden beneath the surface. But the differential rotation never stops. The equator continues to outpace the poles. The magnetic lines continue to stretch and twist, and the tension continues to build. The sun is essentially a giant, self-winding spring. Every second of every day, the internal motion of the plasma is tightening that spring, storing up vast reservoirs of potential energy within the tangled magnetic field. This is the source of the solar cycle, an 11-year heartbeat of rising and falling activity. It is a mechanical certainty of the star's existence. Eventually, the magnetic cables reach a breaking point. They become so tightly wound, so hopelessly knotted, that the laws of physics demand a release. The energy cannot be contained indefinitely. When the snap finally comes, it does not merely ripple the surface. It tears through the solar atmosphere and reaches across the vacuum to touch anything in its path. The quiet observatory in London and the glowing telegraph wires of the past were merely the first witnesses to a process that has been grinding away in the dark for 4.5 billion years. The sun operates on a rhythm that spans approximately 11 years, a celestial pulse that dictates the temperament of the entire solar system. At the start of this cycle, the star appears deceptively serene. Its magnetic field is orderly, with lines of force running smoothly from the northern pole to the southern pole, much like the invisible threads of a spinning top. This is the period of solar minimum, a time of quietude where the solar face is often clear of any blemishes. But beneath this mask of tranquility, the differential rotation is already beginning its work, grinding the internal gears of the star and preparing the way for future violence. As the first year gives way to the second and third, the relentless pace of the solar equator begins to pull the magnetic field lines forward. They are no longer straight. They start to tilt, then lean, and finally wrap themselves around the solar girth like layers of silk being wound onto a spindle. By the 5th and 6th years, The interior of the Sun has become a chaotic mess of magnetic threads. These threads are not merely abstract concepts, they are physical entities of immense power, capable of displacing the very plasma that created them. They become knotted and bunched together, forming dense, invisible ropes of magnetic flux that strain against the weight of the star. When these ropes become too buoyant to remain submerged in the roiling depths of the convection zone, they burst through the photosphere and into the light. These are the sunspots that Richard Carrington sketched with such meticulous care. They are regions of intense, focused magnetic pressure, where the field lines are so tightly packed that they act as a celestial dam. This pressure chokes the upward flow of heat from the solar core, preventing the hot plasma from reaching the surface. Because the energy is blocked, these magnetic islands cool significantly compared to the surrounding landscape of fire. While the rest of the Sun glows at nearly 6,000 degrees, these regions drop to a mere 4,000 degrees. This temperature difference creates a visual contrast so stark that the spots appear as velvet black voids, puncture wounds on the golden skin of the star that mark the sites of profound internal stress. As the cycle progresses toward its 10th and 11th years, the Sun enters its period of maximum agitation. The surface is no longer a smooth expanse of gold, but is instead littered with sunspot clusters, each one a potential site for a catastrophic release of energy. The magnetic field has lost all semblance of its original north to south order. It has become a tangled thicket of loops, arches and filaments that extend tens of thousands of kilometers into the solar atmosphere, the corona. These loops carry trillions of tons of superheated plasma, suspended in the invisible grip of the magnetic field like water held in a net. The tension is now absolute. The celestial clock has been wound to its furthest limit, and the gears are beginning to slip. The laws of physics loathe such a state of extreme, unstable tension. The magnetic field lines are pushed and shoved against one another, forced into configurations that are fundamentally unsustainable. Like a heavy bowstring drawn back until the wood begins to groan, the magnetic field reaches a point of no return. In a process of sudden, violent reconfiguration, the field lines snap. They do not merely break, they undergo a transformation where they cross, sever, and reconnect in a fraction of a second. This is the moment where the star can no longer contain its own internal pressure. When the magnetic field lines rearrange themselves, the energy they held in tension for years is released instantaneously. It is a conversion of potential energy into kinetic and thermal energy on a scale that defies terrestrial comparison. The plasma that was once held in place is suddenly accelerated to millions of miles per hour. Flung away from the Sun by the very forces that once bound it, the snap sends shockwaves through the solar atmosphere, launching blinding flares and massive clouds of matter into the dark. The cycle has reached its crescendo. The star has exhaled, and the shockwave of that breath is now expanding outward, a wall of energy and matter that carries the potential to reset the history of any world unlucky enough to stand in its path. The clock has struck 12, and the quiet years of the solar minimum are now a distant memory, replaced by the raw, unbridled power of a star in its most volatile hour. The moment the magnetic field lines cross and reconnect, the Sun releases its energy in two profoundly different forms, launching a coordinated assault across the vacuum of space. The first of these is the solar flare, a burst of pure light and radiation that spans the entire electromagnetic spectrum, from radio waves to lethal gamma rays. This is the ghost of the explosion, weightless and moving at the absolute speed limit of the universe, approximately 300,000 kilometers per second. From the moment the flare erupts from the solar surface, it takes only 8 minutes and 20 seconds to bridge the 93 million miles of empty space between the Sun and the Earth. It is an instantaneous strike, arriving without a shadow of a warning. The flare bathes the day side of the planet in intense X-rays and ultraviolet radiation. This energy does not reach the surface. The thick blanket of the atmosphere stands as a loyal guard, but it slams into the upper reaches of the air, a region known as the ionosphere. Here, the solar radiation strips electrons from atoms, turning the thin gas of the high atmosphere into a shimmering, highly conductive sea of ions. For those on the ground, the flare remains invisible to the naked eye, but for the radio waves that bounce off the atmosphere to carry human voices and data across the globe, it is a sudden, blinding wall of noise. The flare is the lightning of the solar storm, a flash that announces the beginning of the end of tranquility. But the flare is merely the herald of a much heavier, more tangible threat. While the light is racing away at the speed of the cosmos, a second phenomenon is being born from the same magnetic cataclysm, the coronal mass ejection. If the flare is the flash of a distant cannon, the coronal mass ejection is the cannonball itself. It is a gargantuan bubble of the sun's own physical substance, 1 billion tons of superheated plasma consisting of protons and electrons, physically torn from the solar corona and flung into the void. This cloud is not merely matter, it is a self-contained magnetic structure, a twisted knot of magnetism that carries the sun's internal fury and its specific magnetic orientation into the cold of space. The coronal mass ejection is significantly slower than the flare, yet it possesses a terrifying and inexorable momentum. It moves at speeds ranging from hundreds of thousands to several millions of miles per hour. While the radiation from the flare has already struck the Earth and begun to dissipate, the plasma cloud is just beginning its long, ominous journey across the solar system. It expands as it travels, growing from a localized eruption into a gargantuan front that can eventually span millions of miles, wide enough to swallow planets whole. To an observer positioned in the deep void, it would appear as a translucent, shimmering veil of light, a phantom wall moving with the silent, predatory grace of a tidal wave. The contrast between these two forces defines the anatomy of a solar storm and the nature of the danger it poses. The flare provides the immediate shock, a sudden surge of radiation that can scramble high-frequency electronics and disrupt satellite communications in the blink of an eye. It is the initial blow that softens the defences. The coronal mass ejection, however, is the flood that follows the lightning. It takes anywhere from 18 hours to several days to reach the Earth, a delay that provides modern humanity with its only window for preparation. It is a physical collision between the star and the planet, a meeting of two massive magnetic fields. When this billion-ton hammer of plasma finally arrives, it does not merely affect the upper atmosphere, it deforms the very shape of the planet's magnetic shield. The collision compresses the magnetosphere on the sun-facing side and stretches it into a long, tapering tail on the night side. This physical interaction pushes and pulls at the invisible lines of force that protect all life below, inducing currents in the ground and in the very structures humans have built. One is an assault of information and radiation, the other is an assault of mass and magnetism. Together, they form a two-stage strike that tests every layer of the Earth's defences. As the plasma cloud crosses the orbit of Venus and nears its target, the Earth sits squarely in the path of a billion-ton projectile, a silent, invisible mountain of fire rushing through the dark, destined to turn the planet's magnetic protection into a conduit for chaos. The flash has passed, the warning has been delivered, and now the weight of the sun is about to make landfall. Deep beneath the feet of every living creature, within the crushing pressures of the planetary centre, a sea of liquid iron and nickel churns in a never-ending dance of heat and motion. This is the geodynamo, a titanic engine of molten metal that generates a magnetic field extending far beyond the reach of the clouds and into the cold vacuum of space. This invisible architecture of magnetism is the Earth's primary defence, a protective cocoon known as the magnetosphere. It is not a perfect sphere, but a dynamic, teardrop-shaped bastion, compressed on the side facing the sun by the constant pressure of the solar wind, and stretched out behind the planet into a long, tapering tail that reaches millions of miles into the dark. Under normal conditions, this magnetic shield is a master of deflection. The steady stream of charged particles flowing from the sun strikes the outer boundary of the magnetosphere, the bow shock, and is forced to flow around the planet like water parting around the prow of a ship. This shield is the reason our atmosphere remains intact and our oceans do not boil away into space. It is a silent, tireless guardian. However, the arriving coronal mass ejection is not merely a cloud of matter. It is a magnetic entity unto itself, and its arrival tests the very structural integrity of the Earth's defences. The Sun's billion-ton messenger arrives not as a blunt instrument, but as a key searching for a lock. The outcome of the collision depends entirely on a single characteristic of the plasma cloud, its magnetic orientation. Every coronal mass ejection carries a magnetic field with a specific polarity. If the magnetic lines of the cloud point toward the north, they align with the Earth's own magnetic field. In this configuration, the two fields repel one another like the similar poles of two handheld magnets. The solar storm is largely deflected, its energy sliding harmlessly past the planet and vanishing into the outer solar system. But if the cloud carries a southward-pointing magnetic field, the physics of the encounter shift from repulsion to a catastrophic fusion. In the realm of magnetism, opposites do not merely attract, they seek to merge. As the southward-pointing field of the solar storm slams into the northward-pointing field of the Earth, a process known as magnetic reconnection begins. This is the ultimate breach of the planetary bastion. The magnetic field lines of the Sun and the Earth do not simply touch. They interlace like the fingers of two giants locking hands. In a sudden, violent snap of reconfiguration, the Earth's outer magnetic lines are severed and then re-welded to the lines of the solar storm. This is the moment the shield fails. The Sun's magnetic fingers begin to peel back the layers of the magnetosphere, stripping away the planetary defences like the rind of an orange. The protective cocoon is pulled open, and the energy of the solar storm once held at bay is now funneled directly into the Earth's environment. The magnetic field lines that were once closed and protective are now open, acting as celestial highways that lead straight to the heart of the planet. The superheated plasma of the coronal mass ejection, along with the high-energy protons and electrons it carries, no longer flows around the Earth. Instead, it is caught in the magnetic grip of the reconnection event and accelerated down toward the poles. The particles spiral along the magnetic field lines, gaining speed and energy as they descend, eventually slamming into the upper atmosphere with the force of a cosmic hammer. As the magnetosphere is eroded on the sunward side, the displaced magnetic energy is pushed back into the magnetotail, the long shadow of the field behind the planet. The tension in the tail builds until it too reaches a breaking point. In a secondary burst of reconnection, the tail snaps back like a giant rubber band, flinging even more plasma toward the night side of the Earth. The planet is now being assaulted from both directions. The atmosphere begins to glow as the incoming particles collide with oxygen and nitrogen atoms, creating the brilliant dancing lights of the aurora. To a human observer on the ground, the aurora is a thing of sublime beauty, a celestial ballet of green and red silk. But to the planet, it is the visual evidence of a massive energy transfer. The magnetosphere is no longer a shield, it has become a conduit. Trillions of watts of solar power are being poured into the upper atmosphere, heating the air and causing it to expand. This expansion creates drag for satellites in low Earth orbit, threatening to pull them from the sky. More importantly, the shifting magnetic fields above the Earth create a secondary effect on the ground. As the magnetic lines of the planet vibrate and pulse under the solar onslaught, they induce powerful electrical currents in anything long and conductive. The power lines, the pipelines, and the cables that form the nervous system of modern civilization. The bastion has been breached, and the fire of the sun is no longer just a light in the sky. It is a current flowing through the very floorboards of our world. The date was March 13th, 1989. The world had moved far beyond the age of steam and telegraphs. Cities were now illuminated by the steady hum of alternating current, and the vast frozen wilderness of Quebec was home to one of the most sophisticated power grids on the planet. Deep in the night, while millions slept in the warmth of electric heaters, the sun sent a reminder of its absolute sovereignty. a coronal mass ejection, launched days earlier from a volatile sunspot region, finally made landfall. As the solar plasma slammed into the magnetosphere, it did not merely create a light show in the sky, it began to vibrate the very magnetic field of the Earth. This fluctuation is the key to a phenomenon known as geomagnetically induced currents. According to the fundamental laws of electromagnetism, a changing magnetic field will always seek to create an electric current in any conductor it encounters. On the scale of a planet, the most efficient conductors are not the rocks of the Earth's crust, especially not the ancient, resistant igneous rock of the Canadian Shield, but the thousands of miles of copper and aluminum wires that humans have strung across the landscape. In the early morning hours, these long-distance transmission lines ceased to be mere conduits for man-made power. They became giant antennas, reaching up into the shifting magnetic chaos and capturing the energy of the sun. The Earth's magnetic field was pulsing, and in response, a massive uninvited current began to flow through the Hydro-Quebec network. This was not the controlled, alternating current that powers a light bulb. This was a surging, direct current ghost that the system was never designed to handle. The collapse was breathtaking in its speed. It took only 92 seconds for the sun to dismantle a century of engineering. At 2:44 in the morning, the first voltage fluctuations began. The protective relays, the brain of the grid designed to detect faults, were instantly overwhelmed. They perceived the solar surge as a catastrophic short circuit and began to trip, disconnecting lines in a desperate attempt to save the system. But the surge was everywhere at once. Like a row of dominoes falling in a hurricane, the substations began to shut down one by one. Inside the massive transformers that step up voltage for long-distance travel, a more visceral destruction was taking place. These machines are the heart of the modern world, consisting of enormous steel cores wrapped in miles of copper wire, all submerged in cooling oil. As the geomagnetically induced currents poured into these cores, they forced the magnetic flux far beyond its limits. The steel cores began to saturate. The result was not a graceful failure, but a physical agony of the machine. The transformers began to hum with a low, bone-shaking frequency, a sound of metal under impossible stress. The internal temperatures skyrocketed in seconds. The copper windings began to glow, and the cooling oil started to boil and smoke. In several locations, the heat became so intense that the heavy steel cores literally began to melt, the metal flowing like wax. The insulation charred and disintegrated, leading to internal lightning strikes within the machines themselves. The heart of the grid was being consumed by the very energy it was built to transport. By 2:45, the province of Quebec was plunged into total darkness. 6 million people were suddenly without light, heat, or communication. The subway systems in Montreal ground to a halt, trapping passengers in the subterranean gloom. Schools and businesses closed as the cold of the Canadian winter began to seep into buildings that no longer had the pulse of electricity to keep them alive. It would take 9 hours for the engineers to restore even a fraction of the power, and months to fully repair the physical scars left on the infrastructure. The 1989 event was a watershed moment in human history. It provided undeniable proof that our technological progress has not made us more independent of the cosmos, but more intimately tied to its whims. We have spent the last century weaving a web of metal across the continents, believing we were taming the wilderness. In reality, we were building a giant lightning rod. The very wires that bring us light and information are the same wires that allow a star 93 million miles away to reach down and melt the foundations of our society. The Quebec blackout was a localized warning, a 92-second demonstration of a vulnerability that now spans the entire globe. We have built a civilization of glass and copper, and we have forgotten that we live in the shadow of a furnace. This vulnerability is not limited to the power we use to heat our homes. It extends into the very fabric of how we think, communicate, and remember. The world of Richard Carrington was a world of substance. In 1859, the foundations of human knowledge and commerce were etched into physical reality. Bank balances were recorded in heavy, leather-bound ledgers with iron gall ink. Legal titles were stamped onto thick vellum. Personal memories were captured in silver-hallid photographs or handwritten letters tucked into wooden desks. When the solar storm of that era struck, it could burn the paper in a telegraph office, but it could not reach into the vaults to erase the history of a nation. The resilience of the 19th century lay in its weight, in the fact that information was inseparable from the matter that carried it. In the 21st century, we have traded that weight for the speed of light. We have entered the era of silicon, where the sum total of human experience is reduced to a series of binary states. Our modern civilization is built upon the architecture of the microchip, a landscape of billions of microscopic switches etched into wafers of pure crystal. These switches, or transistors, are now so infinitesimally small that they are measured in nanometers, distances so short they are composed of only a few dozen atoms. This incredible miniaturization is the source of our power, but it is also the source of an unprecedented fragility. The microchips that govern everything from the braking systems of our cars to the heartbeats of our global financial markets operate on incredibly low voltages. They are delicate instruments designed for a world of precision and stability. When a high-energy particle from a solar storm, a proton travelling at a significant fraction of the speed of light, strikes one of these chips, it can cause a single bit to flip. A 0 becomes a 1, a command to stay becomes a command to go. In a localized event, this is a glitch. In the face of a Carrington-class storm, this becomes a global neurological collapse. Consider the global financial system, a structure that no longer exists in any physical form. Trillions of dollars in wealth, the life savings of billions of people and the debt of entire nations are nothing more than electrical charges stored in data centers. These centers, often referred to as the cloud, are in reality massive windowless warehouses filled with racks of servers and hard drives. They are the cathedrals of the digital age, yet they are profoundly vulnerable to the electromagnetic pulses induced by a solar eruption. A massive surge could potentially scramble the magnetic orientation of these drives, turning the ledgers of the world into a soup of digital noise. The bank records would not just be inaccessible, they would cease to exist. There would be no paper trail to follow, no physical ledger to consult. Wealth would evaporate not because of a market crash, but because the medium that held it was wiped clean by the sun. This threat extends far beyond the realm of money. We've outsourced our collective memory to the same fragile medium. Our photographs, our literature, our scientific discoveries, and our personal correspondences are increasingly digital only. We are the first generation of humans whose history is not written in stone, ink, or film, but in the fleeting arrangement of electrons. If a catastrophic solar event were to strike today, we would face a form of digital amnesia. The cloud is not a celestial or immortal realm. It is a physical infrastructure of copper, silicon, and fiber optics that sits on the surface of a planet frequently bombarded by its star. There is a cold, existential dread in the realization that our entire modern history could be reset by a single cosmic hiccup. We have built a magnificent glowing tower of information, but we have built it on a foundation of sand, or more accurately, on a foundation of silicon and light. In our quest for efficiency and connectivity, we've created a civilization that is brilliant but brittle. We move at the speed of thought, yet we are tethered to the whims of a star that does not know we exist. The very tools that have allowed us to conquer the darkness and bridge the oceans are the ones that make us most vulnerable to the fire above. We are a species that has forgotten how to remember without the aid of a machine, and in doing so we have placed our entire heritage in the path of a storm that has been brewing for 4.5 billion years. The sun is not just a source of life, it is a potential eraser of the human story, a silent witness that could, in a single day of magnetic fury, return us to a world of ink and paper if we can even remember how to use them. This silence would not just be metaphorical, it would be a literal, global severing of the ties that bind the continents together. The nervous system of our planet does not reside in the air, but in the crushing, lightless depths of the world's oceans. Beneath miles of salt water resting on the silt of the abyssal plains lies a web of fibre optic cables that binds the continents into a single, thinking entity. These cables are the arteries of the global economy, carrying the lifeblood of the modern world, light. Inside their protective casings, pulses of laser light traverse thousands of miles, carrying everything from high-frequency stock trades to the intimate video calls of distant families. In the quest to understand the true scale of a solar threat, researchers in 2021 turned their focus to these submerged threads, uncovering a vulnerability that could effectively decapitate global civilization. The core of a fibre optic cable is made of ultra-pure glass, a material that is naturally immune to the electromagnetic interference of a solar storm. Unlike the copper telegraph wires of 1859 or the high-voltage power lines of 1989, the glass itself does not care if the Earth's magnetic field is vibrating. However, light loses its intensity as it travels through the dark. To ensure that a signal sent from New York reaches London with its integrity intact, the light must be boosted at regular intervals. Every 50 to 100 kilometers along the ocean floor, the cable is interrupted by an electronic repeater. These repeaters are sophisticated signal amplifiers, and unlike the glass fibers they serve, they require a constant supply of electricity to function. To power these submerged amplifiers, every transoceanic cable carries a thick jacket of copper. This conductive sheath acts as a single, continuous wire thousands of miles long, stretching from one coast to another. It is here that the sun finds its opening. When a massive coronal mass ejection strikes the Earth and induces currents in the crust, these long-distance undersea power lines become massive collectors of geomagnetically induced energy. The copper shielding, intended only to carry a steady, low-voltage current for the repeaters, suddenly becomes a conduit for a surging tide of solar power. The electronic components within the repeaters are designed for a world of extreme stability. They are encased in steel pressure vessels to withstand the weight of the ocean, but they have no defense against a massive internal surge of electricity. In a Carrington-class event, the geomagnetically induced currents would slam into these repeaters with the force of a tidal wave. The sensitive semiconductors would be instantly overwhelmed. In a matter of seconds, the repeaters across the floor of the Atlantic and Pacific Oceans would fail, their internal circuits charred by the sun's indirect touch. The result would be a phenomenon described in recent scientific literature as an internet apocalypse. Because the repeaters are spaced so frequently, the failure of even a small percentage would render the entire cable useless. If a solar storm were to strike with sufficient intensity, the world would witness the simultaneous death of the undersea network. The light would stop flowing, North America would be severed from Europe, Asia would be cut off from the Americas. The global web, which we have come to treat as a fundamental constant of modern life, would vanish. The silence that would follow is difficult to overstate. Unlike a localized power outage in Quebec, which can be repaired in days or weeks, the repair of the undersea network is a slow, agonizing process. There are only a few dozen specialized cable-laying ships in the entire world. To fix a single break, one of these vessels must sail to the middle of the ocean, drop a hook miles deep to snag the cable, pull it to the surface, and splice in a new section of glass and electronics. In a scenario where thousands of repeaters have failed simultaneously across every ocean on Earth, the logistics of repair would stretch from months into years. During this period of isolation, the global economy would essentially cease to function in its current form. Supply chains that rely on real-time data would collapse. The ability to coordinate international relief, manage global food supplies, or stabilize financial markets would be gone. Each continent would become a digital island, trapped in a pre-internet reality while still possessing the high-tech needs of the 21st century. The 2021 research highlights that while we have focused on protecting our power grids, we have left the very bridge between our civilizations unguarded. We have built a global brain, but we have connected its hemispheres with copper-clad nerves that the sun can sever at any moment, leaving us to wander in a quiet, disconnected world, waiting for ships that may never arrive to mend the broken threads of our reality. the silence would not be a mere lack of noise. It would be the sound of a civilization suddenly and violently cast back into the isolation of a previous century. The arrival of a G5 class solar storm is not announced by a roar or a physical tremor, but by the silent, instantaneous collapse of the invisible structures that hold the modern world together. The first casualty is the Global Positioning System, a constellation of 31 satellites that serves as the temporal and spatial heartbeat of our civilization. As the solar flare's radiation ionizes the upper atmosphere, the delicate timing signals, precise to within a few billionths of a second, are scattered and warped like light passing through a shattered lens. On the ground, the precision required for high-frequency trading, cellular synchronization, and automated navigation vanishes. The world's clocks begin to drift, and the digital map of the planet dissolves into a blur of uncertainty. In the cockpits of aircraft crossing the dark expanses of the Atlantic and Pacific, the silence is terrifying. The high-frequency radio bands, the primary means of communication over the open ocean, are swallowed by a wall of solar noise. Pilots find themselves in a void, unable to reach air traffic control or receive updates on the storm's progression. The satellites they rely on for navigation are failing, their sensitive electronics bombarded by high-energy protons that flip bits and scramble memory. For thousands of passengers suspended in the thin air, the modern miracle of flight is suddenly stripped of its digital safeguards, leaving crews to navigate by the most primitive of means, while the sky above them glows with the malevolent green of a displaced aurora. As the coronal mass ejection makes landfall, the silent descent of darkness begins. The power grids of entire hemispheres, interconnected and strained to their limits, begin to groan under the weight of geomagnetically induced currents. In a matter of minutes, the cascading failure begins. Protective breakers trip in a futile attempt to isolate the surge, but the energy is everywhere, flowing through the very ground. Massive transformers, the size of houses and costing millions of dollars, begin to hum with a low, agonizing vibration before their internal insulation fails and they erupt in fountains of sparks and boiling oil. From London to New York, from Tokyo to Sydney, the lights flicker and then die, plunging half the planet into a darkness that is not merely the absence of light, but the absence of function. The just-in-time supply chain, the invisible clockwork that ensures food is on the shelves and fuel is in the pumps, grinds to a halt. Without the internet, without the global positioning system, and without the power to run the massive distribution centres, the flow of goods ceases. Trucks stop in their tracks, unable to receive new orders or navigate the complex logistics of a continent. Grocery stores, which hold only enough food for 3 days of normal consumption, are emptied in hours as the realization of the blackout scale begins to set in. The global economy, a creature of light and speed, is suddenly paralyzed, its muscles frozen by the sun's magnetic touch. The psychological impact on the population is a profound and jarring dislocation. In the cities, millions of people look down at their palms, staring at slabs of glass and plastic that were, only moments ago, their windows to the sum of human knowledge. These devices, now useless without the towers and servers that gave them life, become heavy, cold reminders of our total dependence on a fragile infrastructure. The digital tools that allowed us to feel like gods, capable of speaking to anyone, anywhere, and knowing anything at the touch of a screen, are revealed as mere toys in the face of a cosmic event. There is a thin, brittle line between modern comfort and prehistoric conditions, and that line is the electromagnetic spectrum. As the sun continues its assault, the veneer of civilization begins to peel away. The cooling systems for nuclear fuel rods switch to backup generators, which themselves rely on fuel that can no longer be pumped. Water systems dependent on electric pumps to reach the upper floors of apartment buildings and the taps of suburban homes run dry. The silence of the streets is broken only by the sound of footsteps as people emerge from their darkened homes, looking up at a sky they no longer recognize. For the first time in generations, the inhabitants of the world's great metropolises see the stars, but they are obscured by the shifting, violent curtains of the aurora. The sky is no longer a distant, poetic backdrop. It has become a tangible, threatening presence. The realization that our bank records, our personal histories, and our very means of survival are tethered to a medium that the sun can wipe clean creates a sense of existential vertigo. We find ourselves cast back into a world where the horizon is the limit of our knowledge and the strength of our hands is the limit of our power. The transition from a global, hyper-connected society to a collection of isolated, shivering individuals takes less than 24 hours. It is a reminder that we do not own the world. We merely lease it from a star that is capable of demanding the keys back at any moment. The darkness is not just a lack of electricity. It is the sudden, cold realization of how far we have climbed and how little we have to hold on to if we fall. Against the backdrop of our fragility, a different narrative has been unfolding, one of defiance and unyielding curiosity. For most of human history, we were the passive victims of the solar temper, cowering beneath blood-red skies and interpreting the sun's outbursts as the wrath of distant deities. But the same intelligence that built the vulnerable silicon towers also forged the tools to study the fire. We have transitioned from the era of Richard Carrington, who could only watch from a distance, to an age where we send our emissaries to touch the very atmosphere of the star. The most audacious of these ambassadors is the Parker Solar Probe. Launched in the year 2018, this resilient craft represents the pinnacle of human engineering, a testament to our refusal to remain in the dark. Its mission is to descend into the solar corona, the outer atmosphere of the sun where temperatures paradoxically soar to millions of degrees, far exceeding the heat of the solar surface itself. This is the birthplace of the solar wind and the nursery of the coronal mass ejections that threaten our world. To survive in this hellish environment, the probe must endure a bombardment of radiation and heat that would vaporize any ordinary machine. The shield that protects it is a marvel of material science known as the thermal protection system. It is a sandwich of carbon-carbon composite, nearly 4.5 inches thick, surrounding a core of carbon foam that is 97% air. This shield does not merely block the heat, it masters it. While the front of the shield faces a furnace of nearly 2,500 degrees Fahrenheit, glowing with a dull, white-hot intensity, the instruments nestled behind it remain at a comfortable room temperature of approximately 85 degrees. This temperature differential, maintained across a distance of only a few inches, is what allows humanity to peer into the heart of the beast without being consumed by it. As the probe dives toward the sun, it reaches speeds that make it the fastest human-made object in history, travelling at hundreds of thousands of miles per hour. It crosses the Alphen critical surface, the invisible boundary where the solar plasma is no longer tethered to the star, and begins its journey as the solar wind. Here, the probe effectively touches the sun, flying through the massive loops of plasma and magnetic field lines that Carrington could only sketch from afar. It measures the fluctuations of the magnetic field and the velocity of the charged particles, sending back a stream of data that is slowly unravelling the mysteries of the solar dynamo. This is the transition from victimhood to stewardship. We are no longer content to wait for the red sky to tell us that a storm has arrived. We are placing our sensors in the path of the lightning, seeking to understand the mechanism of the solar cycle and the triggers of the coronal mass ejection. By naming the forces that could erase us, we begin to strip them of their terror. We are building a global early warning system, a network of satellites and ground-based observatories that monitor the sun 24 hours a day, looking for the first signs of magnetic reconnection. The Parker Solar Probe is more than a scientific instrument. It is a symbol of our tenure as the witness. We are a species of the Earth, born from the heavy elements forged in the hearts of long-dead stars, and we have now returned to the fire to ask why it burns. We find meaning not in the permanence of our silicon records, but in the audacity of our reach. To look at the sun and not blink, to send a piece of ourselves into the very fire that sustains and threatens us, is the ultimate expression of the human spirit. We are the first generation that can see the storm coming, and in that vision lies our only hope for resilience. We're no longer just looking at the mirror of history. We are reaching out to touch the glass, seeking to understand the star that holds our future in its hands. Our survival depends on this transition from the seen to the understood, from the feared to the known. For in the heart of the solar storm we find not just the power to destroy, but the raw, fundamental energy that forged the universe itself, and our place within it is defined by our courage to look directly into the light. The sun is not a vengeful deity, nor is it a benevolent guardian. It is a mindless, churning fusion engine of staggering proportions, a sphere of plasma 4.5 billion years old that exists in a state of perpetual violent equilibrium. It does not know that a small blue planet orbits it at a distance of 93 million miles. It does not know that on that planet a species of bipedal primates has spent the last few thousand years building a civilization of increasing complexity. The sun is indifferent to the fragile silicon shells we have constructed to house our bank records, our memories, and our global communications. It follows the laws of nuclear physics and electromagnetism with a cold, mechanical certainty, releasing its energy in bursts that are as inevitable as the rising tide. There is a profound irony in the trajectory of human progress. Our ancestors, living in the shadow of the Stone Age, were largely immune to the solar temper. A Carrington-class event in the time of the Roman Empire or the Ming Dynasty would have passed almost entirely unnoticed, save for the spectacular displays of light in the night sky. The farmers and philosophers of the past were insulated by their lack of technology. Their world was built of wood, stone, and bone, materials that do not capture geomagnetically induced currents. They lived in a world of physical reality that the sun could not touch. We, however, have spent the last 2 centuries weaving a web of copper and light across the globe, believing we were conquering the darkness. We have moved our lives into the realm of the invisible, entrusting our entire heritage to the movement of electrons through silicon. In our quest for efficiency, speed, and connectivity, we have inadvertently made ourselves the most vulnerable generation in the history of life on Earth. We have built a magnificent glowing tower, but we have placed its foundations in the path of a cosmic hurricane. The very tools that allow us to understand the sun are the ones that the sun can most easily destroy. Yet, this fragility is not a cause for despair, but a testament to the profound nature of our tenure as the witness. We are the first generation of life on this planet that possesses the audacity to look at the storm and name it. For 4 billion years, life on Earth has been subject to the whims of the star, but only in the last few decades have we begun to understand the mechanics of the fire. We no longer hide in caves fearing the red sky. We send probes like the Parker Solar Probe to touch the very atmosphere that threatens us. We have built a language of mathematics and physics that allows us to predict the solar heartbeat, turning a source of terror into a subject of study. There is a cold existentialism in realizing that our entire modern history, our bank records, our memories stored in clouds, our global reach, could be reset by a single solar hiccup. But there is also a deep, resonant meaning in the fact that we are here to see it. We are the universe's way of looking back at itself, a collection of star stuff that has gained the ability to measure the temperature of its own creator. We find our purpose not in our permanence, but in our courage to exist in the shadow of such overwhelming power. To look at a solar storm is to recognize the raw, unbridled energy of the cosmos, and to understand that, for a brief moment in the vast timeline of the universe, we were here to bear witness to the light. Our story is not one of conquest, but of coexistence with forces that dwarf our imagination. We remain tethered to the sun, children of its warmth and potential victims of its fury. But as long as we continue to look upward, as long as we continue to build our instruments and refine our understanding, we are not truly helpless. We are participants in a cosmic narrative that began long before our world was formed and will continue long after the last microchip has turned to dust. The sun will continue to churn, the magnetic fields will continue to twist, and we will be here, watching, recording, and daring to understand. If you wish to continue this journey through the celestial narrative and explore the forces that shape our reality, consider joining our community. By subscribing to the channel, you help us continue the work of documenting the history of the universe and our precarious, beautiful place within it. Together, we will continue to look into the dark and find the light.